This is a crab. They live in beaches all over the world. And this is plastic on the beaches where these cute little critters live. It's killing them in the environment. The plastic is a result of people like you littering on the beaches and in rivers which run off the coast and make up 70 to 80% of beach plastics. This pollution not only kills the invertebrates, but us too. We eat these little critters who eat the plastic water bottle you threw away. This means you are eating the water bottle you just threw away on the beach the other day. It not only kills these little fellas, but us too.
According to the IUCN, an estimated 14 million tons of plastic end up in the ocean each year and account for 80% of the debris in the water. This floating trash can be found anywhere from on the surface, buried underneath in sediment, and anywhere in between. As this plastic remains in the ocean, it is constantly being broken down by wave motions and exposure to UV light. The particles that are then taken off of the plastic are able to be eaten by the invertebrates, either on purpose or on accident.
Microplastics can have a lot of effects on invertebrates. Like when ingested, the microplastics could cause them eating problems or even completely block their digestive system. Microplastics can also danger their tissue because of sharp and hard edges. The microplastics can also contain harmful chemicals that can hurt the animals and the environment. This all put together makes a serious threat for our invertebrates and, consequently, our environment.
Pollution of any size in our oceans poses a threat to life all across the planet. These microplastics are dangerous enough on their own. However, when they break down into microplastics, pollution control becomes harder to manage. Due to rough ocean currents and ultraviolet light from the sun, plastics will degrade into microscopic particles that will sink into the sediment in benthic regions. Chemicals from the plastics that are sunken will affect the water quality, and floating microplastics will be affected by persistent organic pollutants. When animals consume these microplastics, the chemicals and additives transfer through the food chain, leading to bioaccumulation of pollutants. This affects higher order species, including us humans, due to biomagnification. The effects of these processes can be seen on beaches on the Atlantic coast, impacting the invertebrates such as crabs. Consumption of these microplastics is so common among suspension and deposit feeders because of the difficulty in differentiating between plastic and prey. The affected organisms include oysters, sea cucumbers, crabs, and other zooplankton. Many predators can be indirectly affected through trophic transfer by consuming these affected prey.
Microplastics are a global threat that not only affect coastal water organisms but also deep sea species. As many surface invertebrates consume it, it allows it to reach the benthos as they die or as it travels down. Within years, there also has been documentation of microplastics in deep sea sediment. This vertical movement of microplastics can be shown by a report done by the University of Oxford, which reported that there are microplastics in many deep sea species such as starfish, sea stars, corals, isopods, and many deep sea jellyfishes.